Alright, this is going to be a challenge problem for some of you guys. So 5-75. The Fibonacci sequence, I think we talked about this in class on Monday. Fibonacci sequence is a famous sequence that appears many times in math. It can describe patterns found in nature, such as the number of petals on flowers, the arrangements of seeds in sunflowers, or scales on pine cones. It's named after Leonardo of Pisa, who was known as Fibonacci. He introduced the sequence to Western European mathematicians in 1202. Though it had been described earlier by others, including mathematicians in India. The recursive equation that describes the Fibonacci sequence can be written as this. So t of 1 equals 1, t of 2 equals 2. So that t of 1 equals 1 means our first term is 1. T of 2 equals 1 means that our second term is 1. So this one, as you can tell, is kind of weird because we start out with our first two terms being 1 and 1. Next part is our recursive. T of n plus 1, so that means our next term equals t of n, so t of n is our current one. Then this one we haven't seen before, t of n minus 1. So if the n plus 1 means the next term, then that means the n minus 1 equals our previous term. So not our current one, the one before the current one, so the previous one. So I'll put previous. Write the first 10 terms of the Fibonacci sequence. So the first term they told us is 1. So our first term is 1. Our second term they also told us is 1. Alright, see if you can go ahead and take a minute, fill in the rest. You can pause your video or something. I'll give you a few seconds to do that. So we're going to add 1 plus 1 to get our next term. So 1 plus 1 is 2. Okay, if we're looking for our next term, which is our fourth term, we're going to take our current plus our previous. So we're going to do 2 plus 1 to get 3. To get our fifth term, we're doing 2 plus 3 to get 5. Go ahead, fill those in, and I'll fill them in. I'm not going to explain all of them though. Again, you're just adding the previous two terms. If that's hard to read, the 10th term is 55. Okay, is the Fibonacci sequence arithmetic, geometric, or neither? So do you see a consistent pattern of adding or of multiplying? Definitely those first few terms are a big hint since it starts with 1 and 1. We're not adding the same thing every time or multiplying the same thing every time. So this is going to be neither. It does not have a consistent pattern. Describe what you would need to do in order to find the 100th term of the Fibonacci sequence. You don't have to actually calculate it because that would take forever. So the 100th term. So the 100th term is going to be our next term. So in order to get the 100th term, we would take the two terms before it. So that would be the 99th term plus the 98th term. We would add them together and we would get the 100th term. So again, it would take forever for you to list all of those, but it's good to know how you could actually calculate it if you really wanted to.